All right, hello everybody. Welcome to Calculus. So we're going to go ahead and get started with limits. That's the first big theme, and this is just an introduction to them. And so first we should define what a limit is. So a limit is going to be, the y value that a function approaches at a given x value. Okay? And so just remember that a limit, where's my highlighter here? There we go. A limit is always going to be the y value of a function, okay? And it's based off the x value. So what you want to do first, if possible, okay, just plug it in to the function. Okay, so the way you would read this first example here is the limit as x approaches 2 of 2x minus 1. And the simplest way to figure out limits is plug in the x value if possible. And so let's see what happens. If I plug 2 into x, doesn't seem like there's any issues. So 2 times 2 minus 1, that's just going to be 3. Okay. Now if that doesn't work, another option that we could use is graphing. So if we know what the graph for the function looks like, you can take a look at the picture. So let me go ahead and graph. Here's y equals 2x minus 1. Remember that that's a y-intercept of -1, slope of 2. And so it's going to look roughly something like that. All right, and so now what we want to do, remember that we're looking at the x value of 2. So if we go to x equals 2, which is right here, we want to find where the function is. If there's a value there, then we're done. And in this case, you can see that y equals 3 right here. And so the answer would be 3 either way, either plugging it in or just graphically. All right, so that's kind of the idea for a very basic example. Next, let's go ahead and introduce one-sided limits. Okay, and so first here's the notation for it. A left-hand limit means we are approaching, so right here, like let's say we're looking at this value up here. Approaching from the left would be like coming this way, okay? Approaching from the right would be coming from this direction, okay? Now, the notation for it looks like this. The limit as x approaches a value, let's say c, and then what we do is put a little minus sign right next to the c, kind of up above, and that tells us that we're looking at the limit from the left-hand side. And for a right-hand limit, it's the same idea. You just do x approaches c, and then you put a little plus sign. That's the only difference. Okay? So now how does that work? So let's go and look at this example here. All right? So if I'm looking at the first example, here we're looking at the value of f of x as x approaches -4. And so I go to -4, and I look at the graph. Is there a value here? Yes. That's going to be 2. Okay? For the next one, now we're approaching 2 from the left. So we go to 2, which is right here. And as we approach from the left, so that means going this way, we do get close to this point. which is going to be 0. Okay, for number 3, if I approach from the right, that's what this notation means here, we're just coming from the other direction, and we're heading to the same point, so the answer for that one will also be 0. The y value at that point is 0. Okay? Let's try a different one. Now, as x approaches 3 from the left, so if I go to 3 and I approach, so here's 3, and okay, so there's no value there, but that's okay. What we want to do is pay attention to just coming from the left-hand side. So if I'm coming along from the left here, traveling along, where am I headed? I'm heading towards this point. Even though there's no point there, I'm getting close to that point, and that's good enough. And so we're going to say that since the y value there would be 2, that we're approaching 2. Okay? And now if I go from the right-hand side, so I'm coming from this direction, from the right side, I'm heading to the exact same point, which has the exact same value of y equals 2. All right, and now here's the big thing that you need to pay attention to. So if I had just said, let's look at number 6 here. Find the limit as x approaches 3. Well, if I go to 3, we already saw that there's no value there. However, since when I approach from the left and when I approach from the right, you see how these both match? They're both 2. That means this limit is going to be 2. Even though there's a hole there, that's okay. We're still going to have a value for the limit. It's just going to be 2 because that's what the value would be if there were no hole. All right, let's try number 7. So let's see how that works. So for number 7, we're approaching -1, so that's this value here, from the left-hand side. So I'm going to find the function. Looks like I'm going this direction. Ooh, that's not very pretty. Let's try again. So I'm moving this way, approaching -1 from the left. I can see I'm heading towards this value right here, which is y equals 3. Okay? But now let's see what happens if I go from the right. So if I approach from the right, so I'm coming from the right side of the graph. So I'm going this way, take a turn, go this way. And now as I get close to -1, it looks like I'm heading towards this value right here, which is y equals 1. All right, and so what does that mean? Well, let me erase this so it doesn't get too confusing. When I look at -1 in general, there's an issue here. This is called a jump discontinuity. We'll get into those later. But that means that because these limits are different, so these limits are not the same, the left side limit and the right-hand side limit are not equal to each other, that means that the overall limit does not exist. The limit does not exist. That sounds familiar. I think that's in a movie or something. Maybe you guys know what movie that is. All right, but anyway, yeah, if you've seen the movie, that's where this comes from. Or that's where the expression in the movie comes from. All right, so that's a little bit about limits. Now let's get into some more analytical stuff. So now we have the existence of a limit theorem. And so the theorem looks something like this. And it's going to basically recap what we just talked about. The limit as x approaches c of a function, f of x, exists if the limit as x approaches c from the left of the function is equal to the limit as x approaches c from the right In other words, if the left-hand limit and the right-hand limit are the same, then the limit at that value is going to exist. All right, so let's go through these last two examples here. And let's spend a little bit of time talking about this one. So you might be looking at this and thinking, I don't know how to graph that. That looks really goofy. So here's what we can do. First of all, notice that x can never equal 0 because you cannot divide by 0, right? You guys hopefully are somewhat comfortable with domain. And now what we want to do is split up. Remember that the absolute value is going to be x if x is greater or equal to 0, but we're not going to do the equal to 0 portion because we just figured out x will never be 0 in this case. And it's going to be negative x if x is less than 0. All right, so now using that, we split this up into two cases. If x is greater than 0, we just do x. The absolute value of x is going to equal x. And so we get 1. But now if x is less than 0, then we know the absolute value of x is going to be negative x. And so we get negative 1. So basically what we get is two things here. We have 1 when x is greater than 0, and negative 1 when x is less than 0. So how does that work? Well, that's just horizontal line at 1, and we're talking about starting it at 0 with an open circle and going this way. Same thing over here, horizontal line at negative 1, but we only want the portion of the graph that is to the left of x equals 0. All right, so now let's see if I can answer these questions. Let me change colors here. So find the limit as x approaches 0 from the right. So if we're approaching, remember, here's x equals 0 right here. So as I approach from the right, looks like I'm heading towards this point right there. So that's going to be 1 for the y value. If I approach from the left, so find the graph to the left of x equals 0, and so we're going to go this way. We're approaching from the left side, and as I approach from the left side, we're heading to this value. Even though there's a hole there, we're headed to a value of y equals negative 1. And so using what we just talked about, this limit, okay, remember that these were open circles. In this case, the limit does not exist because from the right side we get 1 and from the left side we get negative 1. All right? So just remember, if the limits don't match from both sides, the limit does not exist. If the limit from the right and the limit from the left are the same value, then the limit exists, regardless of what you see on the graph. All right, so last example. Here we have a rational function, and one thing that you're going to find is that it's always going to be helpful to factor and simplify first if possible when you're doing limits. Okay? And the reason for that is we're looking at negative 1 for all of these, and you can see right here that if you were to plug in negative 1 in the denominator, you get 0, and we can't have 0 in the denominator. And so usually with rational functions, that's one of the things that, one of the tricks that anyway that will help you is to factor and cancel first. Okay, and so if we do that, I'll do that over here. You can factor the top, the numerator, using difference of squares. That's x minus 1 times x plus 1. Here you get x plus 1 still. Remember that if the factors cancel, you get x minus 1, but that produces a whole at x equals negative 1. Okay? And if you're not sure where the x value comes from here, remember, imagine that you're setting this equal to 0, because that was the whole issue in the first place. And that would happen at x equals negative 1. So now, how do I graph this? So think y equals x minus 1 with a whole at x equals -1. So if I graph that, that's a y-intercept of -1, a slope of 1, so I go up and over 1, that's fine. But when I get to -1 right here, as I get to -1 and I graph that, there's going to be a hole there. Okay, and that's it. That's the graph. Good old y equals x minus 1 with the exception of a little hole at x equals -1. And so now if I look at this picture here, let's look at, here we're looking at the, for part 1, we're looking at the limit from the right side. So we're approaching from this direction, and you can see we're heading towards a value of y equals -2. If I approach from the left side, that's no different. We're still heading to the same location, y equals -2. And so now for number 3, even though the value does not, there's a hole at x equals -1, since the limit from the left and the right are the same, we're going to say that this limit also is equal to -2. Okay, so that's how you would do it graphically. Now, what's the other option? Well, after you factor and cancel, okay, so notice originally you could not plug in -1, because if you were to plug in -1 in the denominator, you get 0. You can't do that, right? But after you factor and cancel, so let me repeat that step. X plus 1's cancel out, you just get x minus 1. Now try plugging in x equals -1. And so you get -1 minus 1. Whoops, getting ahead of myself here. Let me rewrite this. So you plug in x equals -1. You get -1 minus 1, which is equal to -2, and we get the same answer. Okay, so a couple different options here for finding limits with rational functions. First, factor and cancel. That's ideal, especially if there's issues with domain. And now if you're able to plug in the value, that's going to be the fastest way to do it. The other option is if you have a graph, or once you've figured out the graph, you can kind of look at the left side limit, the right side limit, and if they match, then you're going to get a limit value there. All right, so that would be the end of the notes. What I want you guys to do now, before the next class, there are 2 questions here. What have you learned about how a hole affects the overall limit? And what have you learned about the left and right-handed limits and how those affect the overall limit? So just kind of, right now there's really no right or wrong answer. Just kind of want to see where you guys are at and what you guys think. We'll get started with this at the beginning of class. So just make sure you come prepared with something to say there. All right. See you next time.